So in this question, given that limit x tends to infinity, root of this minus root of this is a finite number. If that is so, what should be the value of it? So as you can see, if you put x is equal to infinity in the first expression, you get root of infinity power 4, infinity square. So this number goes to infinity, this number also goes to infinity. So you're getting an indeterminacy of the form infinity minus infinity. So whenever you have infinity minus infinity form, so what you try to do is, you try to rationalize this, you try to bring this into something by something. So that's the usual process that we do, because there is no direct process to deal with infinity minus infinity type of indeterminacy. So what I do is, first I'll try to rationalize this. So if I rationalize this, limit x tends to infinity, obviously I'll multiply this and divide this with root of x power 4 plus ax cubed plus 3x square plus bx plus 2 plus root of x power 4 plus 2x cubed minus cx square plus 3x minus d. So I'll multiply this with the numerator as well as denominator. So now when I multiply this with this expression, so I get a square minus b square type of expression. So x power 4 plus ax cubed plus 3x square plus bx plus 2 minus of x power 4 plus 2x cubed minus cx square plus 3x minus d. So in the numerator, as you can see, x power 4 and x power 4 gets cancelled. That is equal to limit x tends to infinity. So you get a minus 2 times x cubed plus 3 plus c times x square plus b minus 3 times x plus 2 plus b divided by root of x power 4 plus ax cubed plus 3x square plus bx plus 2 plus root of x power 4 plus 2x cubed minus cx square plus 3x minus d. So once you have this, we'll use our general shortcut when x tends to infinity. So we know that as x tends to infinity, only the highest power of x matters, because you have in the numerator also you're going to infinity. If you put x is equal to infinity, in the denominator also you're going to infinity, right? So you have infinity by infinity form and x is going to infinity, hence only the highest power of x matters. So in the denominator, you can neglect all these powers when you are dealing with x power 4. Similarly, you can neglect all these powers. So effectively, the highest power of x in the denominator, root of x power 4 is x square, root of x power 4 is x square. So you have an effective 2x square in the denominator. Now, in the numerator, the highest power is x cubed, in the denominator, the highest power is x square. So this is not good, because if the highest power of x in the numerator is more, that is, if I neglect all this, x square will get cancelled with x cubed, you get an x in the numerator. As x tends to infinity, the limit goes to infinity. The limit goes to infinity, right? So I don't want that, because in the question it's given that the limit is finite. So denominator is fixed, it is going to 2x square. So if the limit has to be finite, in the numerator also, you have to have the highest power of x as 2. That means this x cube power should not exist. That means the coefficient of x cube has to be equal to 0. So a has to be equal to 2. So a has to be equal to 2, and if a equal to 2, this whole term disappears. In the numerator also you have x square as the highest power, so you can neglect all this. So x square and x square gets cancelled, and the limit is 3 plus c by 2. So this is the value of the limit. This is the value of the limit, and this is a finite number, and this happens only if a is equal to 2. So this is the answer to this question. A is equal to 2.